of this arithmetic, geometric, and what's the other one, quadratic. But here we're only covering the series for arithmetic and geometric, and it's just up here. So this is the general formula for arithmetic, and then the sum of arithmetic series is this one. This is the formula for it, and then the formula for the last term is that one, and then given a last term, the formula for the sum of arithmetic series is this one. Okay, how does a series look like? This is an example of a series. The first 25 terms of 18 plus 13 plus 8, you see they are adding numbers, and here we see we are decreasing by 5, and then the numbers continue because of those dots. But we want the sum of the first 25. So this type of equation is called the series. We are summing the series. We want to sum the series. Okay, what do we need to sum the series for the arithmetic? We need the first term. We need to know how many terms we're summing. In this case, it's 25. And then we need the constant difference. In this case, I've already said that the constant difference is 5. In this case, it's actually negative 5 because we are decreasing. And then you put those things into a formula. And then you'll have that the sum will be minus 1050. So literally just putting those things, which is the difference, the number of terms you're summing, and also the first term being 18. And then the other type of equation is you have a series that they don't tell us how many terms are in the series, but they tell us the last term. So given the last term, we can be able to know how many terms are in the series. Okay, so looking at the formula for the last term, for finding the last term, we already have the last term is 35. So when I say 35 is equals to 5, which is the first term, and then you have n minus 1 times d, and our difference in this case is 3, because 8 minus 5 is 3, 11 minus 8 is 3. And then with that, we can quickly solve and find that n is equals to 11. So the total number of these terms, in this case, in this series, there's 11 terms, and we want to sum for those 11 terms. So again, since we have the last term, we can either use this formula or use the very first one for summing these 11 terms. When we use the last formula, we're going to have 11 over 2. We're going to have 5 as the first term plus 35, which is the last term, and that gives us 220. And this is the sum of the series given a last term. And then these type of questions, they're more extensive. We'll do them on question papers, but we quickly can go to the geometric series, in which we also explore the general formula of the geometric series. We know it already, but then we have the sum of the geometric series. If r is less than 1, the formula is like this, and then if r is greater than 1, the formula is like this. So you have to check your r, how your r is, and then it's a open bracket 1 minus r squared. The r there is the common ratio. The a is the first term, and we know what n is. It's the position. So it's just a bit of shifting between these formulas based on the value of your r. So in this case, you are starting with the r. In the other case, you are ending with the r. So that's the only difference. Okay, now to put this into action. Given this series, you have minus 2, you have 6, you have minus 18, you have 54. And then you need to find the ratio. The ratio is r is equals to term number 2 over term number 1. And in this case, we get minus 3. So minus 3 is the ratio, the common ratio. And then since minus 3 is less than 1, we have to use the first formula. To address this. And then we just substitute the ratio, and then we substitute the number of terms we're summing, because they already said we're summing 9 terms. And then we substitute the first term, which is minus 2. And then with that, we can be able to get minus 9,842. And then the next question, the value of n if the sum of the series is minus 797,162. So this is the sum. We want to know how many terms they have summed in order to get this. Okay, it's still the same question, still the same ratio, and then still the same a, which is minus 2. But here, instead of wanting Sn, we already have Sn, which is that minus big number. We're looking for n. So we substitute everything, and then what we do is the denominator here is going to be 4. It's going to be 1 plus 3, which gives us 4. So at the bottom here, you're going to have 4. And then to get rid of that 4, you must multiply both sides by 1 over 4. Is it? No. You must multiply by 4, because this 4 is at the denominator. So to cancel it, we multiply by 4. So in that case, the other side will also be multiplied by 4. That's why you get minus 3,188,648. So Now we'll be left with the numerator on the other side. The numerator starts with a minus 2. The minus 2 you can divide by it both sides. Divide by minus 2. Also here divide by minus 2. And then this side will be left with a 1,000,000.5. So 1,594,000 and all of that. That side the minus 2 goes away. You now have 1 minus 3 to the power n. And then you can take the minus, the base with the exponent, the minus 3 to the other side, and it will be positive. You leave the 1 here, and then you take the million to the other side. So this side will have 1 minus that million, because the million, when it comes from here and goes to the other side, it must change sign. And then this one, it goes to the other side, it changes sign. And then this minus 1,594,323 is the same as minus 3 to the power 13. So that you have to test using your calculator. It usually works. So you check the base of the other one, and then you take that base, you put exponents until you can find something that is similar to this million. And then in this case, since the bases are the same, it means that we have summed 13 terms, n is equal to 13. So this is another basic question that they like asking. And also, like the previous one, we have these questions that are not general, but they are easy to do, but we address them with the question papers. Then the last part will be taught in class, really. Yeah, the last part will be taught in class in an extensive way. For now, I think that's all we cover for the sequence and series, and I think that's what's sufficient for the examples that we're going to do in the past question papers. Thank you.